Hello and welcome to this second video in the series on trigonometry, and this is just a quick video looking at the sine rule, because sometimes the sine rule, depending on the information you're being given, things can get a little bit sneaky. So we're going to have a look at what's referred to as the ambiguous case of sine rule. Okay, so here we go. So we're going to solve problems using kind of this ambiguous situation. So here we go. What's going on is we've got some information about a triangle, so let's just see how we can draw that. So I'm going to start by drawing it. There's my line AB. I know it seems a little bit weird to start with that one being the diagonal line, but it just made life drawing a diagram just a bit simpler. So we've got that length, AB, and we've got a 40-degree angle at BAC. And now the key thing here is I want to draw the line BC such that it's 4 centimetres long. So what we need is the point C. We know is going to be somewhere along this line. And we know it's got to be 4 centimetres from this point. So essentially what that means is that C is the locus of the points 4 centimetres from B. And if you remember back to the good old days of drawing locuses with pairs of compasses and stuff, you'll know that effectively the locus of the points 4 centimetres from B is a circle. So what we get is a line looking like that. So we can see now straight away you've got 2 points, one there and one there, that are 4 centimetres from B. So what that means is essentially we could draw 2 separate triangles. And therefore if we're being asked to calculate, say in the question, we're being asked to work out the size of angle C, we've got 2 triangles. We've got one angle C here that would be obtuse and another one here that would be acute. So you get 2 possible values. So let's say it's not entirely straightforward. So let's just have a look at those 2 triangles and see what happens. So there's the first one with C1 being our obtuse angle, and there's the second one with C2 being the acute angle. And again, those 2 triangles, although they look completely different, are both drawn with the information given in the top line here. They've both got exactly that information in them, but it's enabling me to draw 2 different triangles. So what we're going to do now is go for finding the size of the angle. So let's have a go. Here we go. Sine rule. Sine C over 6. So there's that pair, and there's my other pair, which is sine 40 over 4. And just do the rearranging, and away we go. We've got an angle of 74.6, but we should know that we actually get 2 angles between 0 and 180 that we can get from here. And depending on how you do it, I'm always before drawing the curves, but if you're a cast person, then obviously you'll be using cast to do this. And we can see from the sketch of my sine curve that I've got my other value, which is 105.4, which is the 180 minus 74.6. So I've got 2 values. That C1 would be the 105.4, C2 would be the 74.6. I'd say 2 different angles, both coming from the same triangle.